Imagine trying to write the number 105 without a zero. The Romans had no zero. They wrote 105 as CV, a different symbol entirely. And that meant Roman mathematics could not do what we take for granted. You cannot write large numbers cleanly without a placeholder. You cannot do long division. You cannot build a positional number system. You cannot do algebra. You cannot do calculus. And this is exactly why Rome, one of the greatest empires in human history, never developed advanced mathematics. Not because Romans were not brilliant, but because they had no zero.
The first civilization to come close was Babylon, in what is now modern Iraq, around 300 BC. Babylonian mathematicians using a base 60 number system were the first to realize something was missing. When they wrote numbers in clay using cuneiform script, they sometimes needed to show that a position was empty. So they invented a placeholder, two small slanted wedges pressed side by side into the clay, meaning not a value here. And this was genuinely brilliant. But it was only a placeholder, not a number. You could not add it, subtract it, or multiply with it. On the other side of the world, with zero contact with Babylon, completely independently, the Mayan civilization of Mesoamerica invented their own zero. Around 350 AD, they used it in their extraordinarily precise calendar system. Their symbol for zero was a shell shape, elegant and deliberate, and their zero worked as a placeholder inside their base 20 number system, allowing them to track astronomical cycles with accuracy that astonished modern scientists. But like the Babylonians, the Mayan zero was not yet a full number. It was a marker, a gap, a position indicator, not something you could calculate with on its own.
The story now moves to India, to a mathematician and astronomer named Aryabhata, born in 476 AD near what is now Patna in Bihar, who wrote a text called the Aryabhatiya at just 23 years old. This text did something the Babylonians and Mayans had not done. It used zero not just as a marker in a specific system, but as a genuine position in a decimal place value system, the same decimal system the entire world uses today. Aryabhata did not give zero a symbol or define it philosophically, but he used it functionally, treating it as a real position that controlled the value of every number around it. And his work on pi, on trigonometry, and on the decimal system laid the foundation for what was about to happen next.
In 628 AD, a mathematician named Brahmagupta, born around 598 AD in Rajasthan, India, wrote a book called the Brahmasfuta Siddhanta, the correctly established doctrine of Brahma. And in that book, he did something no human being had ever done before in recorded history. He defined zero as a number with its own mathematical rules. A number minus itself equals zero. Any number added to zero remains unchanged. Any number multiplied by zero is zero. These sound simple now because we learned them in primary school. But in 628 AD, these were revolutionary axioms that changed the entire architecture of mathematics. Brahmagupta also defined negative numbers for the first time and gave the world the concept of debt as a mathematical value.
Zero did not stay in India. It traveled. And the man who carried it most powerfully westward was a mathematician you have met before in this channel, Muhammad ibn Musa Al-Khwarizmi, working at the House of Wisdom in Baghdad in the 9th century AD. Al-Khwarizmi studied Indian mathematics, including the decimal system and zero, and wrote a book explaining the Indian numeral system to the Arabic-speaking world. This book was translated into Latin in the 12th century in Baghdad, and it introduced zero and the decimal system to medieval Europe. The numerals we call Arabic numerals today, the 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 you write right now, are directly descended from the Indian system that Al-Khwarizmi brought to the Western world. When zero arrived in Europe, it was not welcomed. It was feared. In 1299 AD, the city of Florence, Italy, actually banned the use of zero, along with the rest of the Hindu-Arabic numeral system. Officially, because merchants were worried that the symbols could be fraudulently altered. Unofficially, because the Catholic Church was suspicious of a number that represented nothing. A number for the void felt philosophically dangerous. Some called it the devil's number. Some theologians argued that only God could create something from nothing, so a number that represented nothing challenged divine authority. For over 2 centuries, European merchants secretly used zero in their calculations, hiding a number that the future of their entire civilization would be built on. Once Europe accepted zero fully, the world changed fast. Zero made calculus possible. Isaac Newton and Gottfried Leibniz both developed calculus in the 17th century, a mathematics of change and motion. And calculus requires the concept of approaching zero, limits that get infinitely close to nothing. Without zero as a real number, calculus cannot exist. Without calculus, there is no modern physics, no understanding of gravity, no orbital mechanics, no space travel. And then in the 20th century, zero did something even more radical. It became the foundation of all digital computing. Binary code, the language of every computer ever built, is built entirely from ones and zeros. And without zero, there is no binary, no computer, no internet, no digital world.
There is one more dimension of zero that most mathematics classes never mention. Zero is philosophically strange in a way no other number is. You cannot divide by zero. Try it on any calculator and it returns an error. Not because the calculator is broken, but because division by zero is mathematically undefined. It produces a result that is simultaneously infinite and meaningless. Zero is the only number that collapses mathematics when used as a divisor, and mathematicians still debate what this means. In philosophy, zero represents the void, the concept of nothingness. The Buddhists called it sunyata, emptiness. The Sanskrit word for zero, shunya, literally means empty. And Brahmagupta, the man who defined zero mathematically, was working in a philosophical tradition that had no fear of the void.
Zero was not discovered, it was invented. Slowly, across thousands of years, by multiple civilizations, each getting closer until one mathematician in 7th century India finally completed what everyone else had only started. The Babylonians found the gap. The Mayans named the gap. Aryabhata used the gap. Brahmagupta made the gap a number. Al-Khwarizmi carried that number to the world. And the world built everything digital, everything computational, everything modern on a number that means nothing and turned out to mean everything.